All right, so for this first problem, this one's picking up on stuff that we've done before, although I am going to be able to maybe add one more piece to your repertoire on it. We'll see. All right, so first thing you want to do, make sure you remember what each of these inside, what these numbers do. The number inside, the -6, remember that goes to the right. The -9, it's hanging on the end, so it goes down. So we go right, 6, down, 9, plot your first point there. And then once you have that first point plotted, then it's making the same old quadratic graph that we always make. And again, I know it's quadratic because I see that squared there. So I follow the pattern of over 1, up 1 on both sides. Then over 2, up 4. Notice when I say over 2, I'm counting from the first point there. So over 2, up 4 on both sides. Then we go over 3 and up 9 on both sides. And then this is the point where maybe I'm going to add something to your repertoire. Because from here, we normally can stop there. Normally that's enough. But not in this case. We can actually fit on some more points. If I go over 4, how far up should I go?
Up 16.
Up 16 is right. Because remember why I go over 3 and up 9. I go over 3 and up 9 because 3 squared is 9. In other words, 3 times 3 is 9. If I do 4 squared, or in other words 4 times 4, I get 16. And so then we can go over 4 and up 16 as well. So plot those points if you didn't already, and then you can go ahead and draw your U-shaped graph that goes through those. And we have our graph completed. All right, so for this one now, this looks very familiar, very much what we're used to seeing and doing, but there is one thing different from what we've done in the past, and that is that minus that's out front of the absolute value. And it's about saying what does that negative do to the function. Basically, what this is going to do is going to take our normal graph, which, by the way, what does the normal shape of this graph, what is it? Yep, it is a V shape normally. And so the difference is that instead of being a V opening up, that negative is going to make it into a V opening down. Basically, what that negative out front does is it flips it upside down. Or if you like the technical math language, it is a reflection across the x-axis. All right, so how do I handle that? Well, first of all, let's again see what the 3 and the 5 do. Which way does the 3 move it? Up, down, left, or right?
Left.
Yep, it goes left. Notice the fact that we had a negative in there did not change that. The +5 hanging on the end, which way does that move it? It moves it up. Again, that negative did not change it. And so our starting point is still going to be left 3, up 5. The negative does not change that. When we flip this thing upside down, it means that from that point, I'm going to be opening downward. It does not mean that I take this point and flip it as well. So it tells me I'm just opening down from that point. So once you have that, we know we're going over 1, down 1 on both sides. And so keep putting those points out to the edge of the grid, then break out the straight edge and draw your graph in. And so you make your graph, draw the line in that goes through it, and you're done, right? So this is it. Next equation, please write this one down above your next graphing grid. All right, and then when we go to make this graph, again we think about what everything's doing in here. The negative is again out front. It's going to do the exact same thing. It's still going to flip it upside down. And so the other numbers in here, the -1, still going to go right 1. The -3, still going to go down 3. So go right 1, down 3, plot your point. And then I'm drawing the square root graph. Now remember that the square root graph normally is doing one of these. That negative out front is going to flip it upside down. So instead of going over 1, up 1 for my first point, I'm going to go over 1, down 1 for my first point. And then the second point, normally I'm going over 4 and up 2 because the square root of 4 is 2. In this case, it's going to be over 4 and down 2. Same thing. The only difference is I'm going down instead of up when I plot the points. And then for that last point that we can actually fit on there, normally we go over 9 and up 3 because the square root of 9 is 3. So in this case, you can see we're going to still go to the right 9. Going to the right doesn't change, but we're going to be going down 3 instead of up 3. All right, so for this one, the plus 4, and actually this is one that sometimes gets us tripped up. This plus 4, it's hanging on the end. Notice it's not stuck inside parentheses or something with the x. Therefore, that plus 4 is going up 4, not over, because there's nothing trapping it inside with x, so it's up and down. So we're going to go up 4, and that's all we're doing. We aren't going over at all. So I plot the 1 point, first point, up 4. And from there, normally, I'm going over 1 and up 1. And so for in this case then, it's going to be over 1 and down 1. And the interesting thing with this one is that because it's a line, we can also go back to some language about slope. Notice your slope here ends up being a -1, and you can see that negative slope in action because we're actually kind of traveling downhill on our graph, if you want to think of it that way. As we read left to right, it's sloping downward, hence negative slope. So once we found our starting point that's left 1 down 6, we're making our normal U-shaped graph that we do, but instead of opening upward, it of course is going to be opening downward. So I go over 1, down 1 on both sides. Then I go over 2, down 4 there on both sides. Right, and so when we go and make the graph for this one, we start left 6, up 4. Because we have the negative out front, that means we're going down instead of up as we make our square root graph. But we can actually, again, plot one more point on here because normally that one's enough, going over 9, down 3. But we can actually plot one more in this case. Now remember, the reason why we go over 9 is because I know what the square root of 9 is. What's the next number where I know what the square root of it will equal? Yeah, so 16 is the next one. And notice in this particular case, I actually can go over 16. Just barely, but I can go over 16. And so I'm going to put one more point right over there. And then once you've plotted that point, then you can go ahead and draw your curve that goes through those points again.